Okay, today I want to give you a few examples of writing or drawing truth tables. The first case here is problem 18 from page 177. It's the statement Q, if and only if P or not Q. And I want to construct a truth table. The first thing to notice is that there are two propositions in this particular problem. There's a P and a Q, which means that there are going to be four different cases that we will need to address in our truth table, or four different rows in our truth table. So we begin by drawing a column for P. You always begin truth tables this way, and a column for Q. And we list the four different ways that their truth values could be. So they could both be true. P could be true and Q false. P could be false and Q true, or both could be false. And then our object is to figure out what's the value of this entire statement depending on the truth values of P and Q. So I like to begin by writing the statement across here and leaving columns where necessary. So we have Q, we have the biconditional, we have P, the disjunction, and then the negation of Q. And the first thing to do is to go through and fill in the columns that are simply P, Q, or the negation of either one. So this column is just a copy of the column for Q that we've already written, and this will be column 1. P is also just a copy of the first column over here. That's the second column. And then not Q should be the negation of Q, so we do the opposite. False, true, false, true. And that'll be the third column that we fill in. Now it's not necessary to number these, I just number them in order to be able to talk about them. Now the order in which we fill this in is dictated to us usually by parentheses. So just like arithmetic or algebra, we got to do this stuff inside parentheses first. So now that I've filled in those three columns, the first operator I'm going to work with would be the disjunction right here because it's inside the parentheses. So I'm forming the disjunction of columns 2 and 3. Now the rule for disjunction, something you're going to have to remember, is that the disjunction is only false if both items you're comparing are false. It is true in every other case. So if either one of the items you're comparing is true, then the disjunction is true. So I've got true or false, that's true. True or true is true. False or false, that's the one case where it's false. False or true is true, and I'll call this column 4. Now since I used columns 2 and 3 to create column 4, I will never use these columns again, so if you want to draw a line through them so as not to confuse yourself, to get rid of them, that's perfectly all right. So the last thing I have to figure out, this last column, is the biconditional. And this is going to be my answer column since it's the last column I fill in. And the only two columns I have to compare that I haven't marked out are columns 1 and 4. So those are the two I'm using to work with the disjunction, with the biconditional operator. The rules for the biconditional is that it's true when the two things you're comparing have the same truth value. That is, if they're both true or if they're both false. So for the first row here, columns 1 and 4 are both true, so the biconditional is true. Second row, this one is false and this one is true, so they're opposite, so that's false. These have opposite truth values, so false, and these have opposite truth values, so false. So this is column 5, and this is our answer column. So we can say that this compound logical statement is only true in one case. It's true if your statements P and Q are both true. If P and Q have any other combination of truth values, this compound statement will be false. And that's how you do a two-statement truth table. Okay, now we have a three-statement truth table. We have P, Q, and R, which means there are going to be 8 cases in your truth table that we're going to draw. I have to draw this one a little smaller to fit it into the screen here, but you need to start off by having columns for P, Q, and R. So there's 8 different cases. This is what we have. Okay, once you've done this a lot, you can figure out the pattern very quickly and you know what to draw. But the basic idea is if you're trying to draw this yourself, you could look at it in terms of columns instead of rows as I filled it out. Notice that the first column has 4 trues followed by 4 falses. The second column's 2 trues, 2 false, 2 trues, 2 falses. And the last column alternates true, false, true, false. That will get you all 8 of the cases necessary. And now we need to draw our compound statement across the top with all the necessary columns. So a column for P, a column for the conjunction, a column for Q, a column for the conditional, and a column for the negation of R. And the first thing we're going to do is fill in each of the columns for the simple statements, P, Q, and the negation of R. So these are just copies. Just copying column P from over here to the left. And now I'll copy column Q. And then I'll do the negation of R. Okay, so these are my columns 1, 2, and 3. That's the order I filled them in. Okay, so working inside the parentheses, I need to do the conjunction first of columns 1 and 2. The rule for the conjunction says the conjunction is only true if both things you're comparing are true. So that's true here and here because both are true. Everywhere else in this column you're going to get false because at least one of the statements is false. And I'll call this column 4. I used columns 1 and 2 to make column 4, so I'll never use those again. And the last column I have to fill in is the conditional column. It's going to be my answer column. And I'm going to fill in this column based off of columns 4 and 3. The rule for the conditional says that it is only false if the first item you're comparing is true and the second one is false. So this very first row is false because this one's true and this one's false. And I'm going to go through here and see if there's any others. There's no other places where we start with true and end with false. So all the rest of these cases end up being true. This is column 5, and that's our answer column. So this particular compound statement always ends up being true except in one particular case. The one time this compound statement is not true is if P, Q, and R are all initially true themselves. And so this is an example of a 3-statement truth table.